Hi, welcome to the next video of the course of Persistent with C++ and Qt. My name is Carlos and we're going to start with a new video where we're going to implement the isable Modus Tollens function. So we can do something like this. Follow symbol under the cursor. And I already implemented to make the video faster. So what it does is something similar that is several Modus Tollens, but the only difference, the two differences is the log here, and that the second boolean is returning from the is closure function instead of is a cube. So if you might remember, if it's Modus Tollens, we need to have something similar like this, right? For the Modus Tollens, there are only and between the atoms. That's right. So this is Modus Tollens and this is Modus Tollens. So the next step is to configure knowledge base. And these two functions are Modus Tollens, and the last one is Modus Tollens because it has an OR operation among these nodes. Okay. Then we have a new function, additional function that is log only for functions. That it has a macro. What this macro does is to expand a string that describes the function and that the parameter is calling. So we put this macro inside this function is going to throw or to log the name of this function, and the reason of this is to make a separation among the functions to know where is the book and where the book was thrown. And maybe we have a series of calls or function, and the first one is able Modus Tollens and the second one is able Modus Tollens. So we can actually write here log only for Q. Okay. So this is the first call and the second call. If we have a book inside of isable Modus Tollens, we're going to have a log in the application output. I think that we have like this one. And if the system exits unexpectedly inside this function, and we have a call of isable Modus Tollens after isable Modus Tollens, these calls won't appear, and we therefore will know that the bug is inside of the isable Modus Tollens, right? So the implementation is quite easy. Is just create a node from the entry, create two local booleans. After that, we know that the rules are their index is the if node in the entry. So we're going to return, this is if I remember what is recursive calls of this cube from the node first, the antecedent of the if rule, and it's going to return if it's cube or not. Hopefully it will be true. And the second bool is able to have a closure. I mean, if the is a closure, it's going to return a true, and we are using the consequence of this of the current rule. So hopefully it will return true also, and if any of them is false, we don't have a rule that is able to work with Modus Tollens, so we're going to return false. If this is not the case, we can insert the rule type Modus Tollens. I think that I changed this part because we have a boolean that is false. Well, I think that is not a good idea because the reader won't understand what's the reason of this false. So I prefer to create a new enum. I think that it's in the workspace here. And I said to the value of 0, that is the same to not change the implementation or other function that we already implement. Modus Tollens is 0, Modus Tollens is 1, and no type is 2. So we just change it that way. We also change this part. The next step is that just have a log saying that the rule is Modus Tollens. I think that is like this one, and return true. Otherwise, if we index in the rule of a tree entry that is not if, actually we're going to have a lot of errors. So in this function we're going to try to avoid that and say else we're going to set throw prompt an error, and we're going to return false to acknowledge the user that the able modus tollens didn't work. The only case and the only way that we're going to insert to the rules is by returning true, right? So next step is to go to the test, and this is one. I'm going to set two functions that are those two. Is a modus tollens rule, one rule that is relevant to have work with the modus tollens, another one that is not good idea to work with modus tollens. So we can go to the function. When doing pretty much the same among all the functions that we're testing. We're creating an attribute builder, the lex analyzer, construct the infinite sigtas analyzer from these two last objects. Then we access the file, we compile, and we create the inference kernel object, and then we verify if it's able modus tollens with the rule that, if I remember well, is working with able modus tollens. And we have another one that is pretty much the same, but with a function that is not modus tollens. So if we run this, I think that I need to rebuild the inference engine. Erase and close those functions, those windows. So we go to the source, run the application, go to application output, and say forward chaining. A lot of logs for the forward chaining. Okay, it's able modus tollens. We have pass test inference kernel is able modus tollens Modus Tollens rules, and we have a log, qdebug log that says that indeed, this is the log that we have in this function, this one. This is the log that we create from that code, and just pass. But the second one, that is not sustainable to work with Modus Tollens. It says, well, I entered to the function, but it failed because the 11 is not a rule to work with Modus Tollens, so it returns false. And that's it. I think that we are testing the two cases that we have, that is if we're indexing an index, that a tree index that is not Modus Tollens sustainable, and another one that is sustainable to Modus Tollens. So I think that this is for this video. I hope you enjoy it. We're going to go to the next step that I also, sorry, but I also implemented, because we need to do a lot of tests, and it's the function are verified new conclusions. So see you.